Hello everyone, myself Shweta Mannikeri, working as Assistant Professor in Computer Science Department in Government First Grade College, Bangapet. Operating System is a syllabus for BCA 3rd semester for Bangalore North University. Today we will discuss about session 8. Today's objectives are CPU scheduling. In CPU scheduling there are two types. We learn those two types as preemptive scheduling and non-preemptive scheduling, and CPU scheduling algorithms. In that today we will discuss first come first serve algorithm and shortest job first algorithm and priority scheduling algorithm. CPU scheduling is one of the very important function of an operating system. CPU scheduling is a process which allows one process to use the CPU while the execution of another process is on hold, or if it is into waiting state due to unavailability of any resources like input output. What it means if CPU is executing one of the process, if it enters into any waiting state by making requesting for any input output devices, and if that any of the resource is not available, it will enter into waiting state. That time CPU will switch from that process to another process to execute. For example, if process P1 is executed by the CPU, if in between it requires any printer and it start requesting for printer, that time any printer is not available in the system, it will enter into waiting state. That time CPU switch from process P1 to another process P2 and start executing. With this, CPU will never be idle and it has any one process to execute. This CPU scheduling makes maximum utilization of resource such as CPU. Whenever process enters into any waiting state, and it makes the full use of CPU and it gives the output very quickly. In this case, CPU never be idle and it has at least one process to execute. This is how most of our modern operating systems makes CPU utilization maximum and gives the output very quickly. And CPU scheduling makes the system efficient, fast and fair. Most of our modern operating systems such as multi-programming operating system, distributed operating system and time-sharing operating system makes maximum CPU scheduling and maximum utilization of one of the resource such as CPU. Because if CPU is idle, we will get the output very we will not get the output very quickly. That's why CPU should be busy with at least one process to execute. In CPU scheduling, there are two types. One is preemptive scheduling and another one is non-preemptive scheduling. Let us discuss what are the preemptive scheduling features and non-preemptive scheduling features. In non-preemptive scheduling, if any one process is allocated the CPU, it does not leave unless it requests for any input output or if it is in waiting state. Means if process P1 is executing by the CPU till it finishes, or if it is into waiting state, it will not leave the CPU and it will not make chance to get another process to enter into CPU. If process 1 enters into CPU, it will till it terminates, it will enjoy the CPU. It will not give any chance to another process to execute. Like that, non-preemptive scheduling will work. In preemptive mode of scheduling, where operating system force or preempt a process from the CPU at any time to allocate CPU to another higher priority process. For example, if process P1 is executing by the CPU, at the same time another higher priority process P2 comes into the ready queue, that time operating system will makes the forceful preempt P1 from the CPU and allocate process P2 to execute by the CPU. Means whenever higher priority process comes into ready queue, whichever process is executing, it will be forcefully preempt from the CPU and give chance to another process to execute. CPU scheduling decision may take place when a process switches from running to waiting state, or switches from running to ready state, switches from waiting to ready queue, or if any time if process terminates. Scheduling under 1 and 4 is non-preemptive and all other scheduling are preemptive. Mainly we will come across preemptive and non-preemptive scheduling, depends on the strategies. Dispatcher is a module gives control of the CPU to the process selected by the scheduler. Whichever process select by the scheduler, the dispatcher will take that process and keep them into running state, and it will allocate CPU for execution. Dispatch latency is a time it takes for the dispatcher to stop one process and start another running process. Means this is a time taken by the dispatcher to stop one process and start another running process to allocate CPU for execution. Scheduling algorithm optimization criteria means there are two major things we have to maximize and three things we have to minimize. What are the things we have to maximize? Means CPU utilization, means 100% utilization of CPU, and CPU never be idle. It will be busy with any one of the process till it completes one process and it switches to another process. If process P1 is requesting for any input output, the CPU will switch from that process to another process and it will never be idle. Always we have to make CPU utilization maximum. And throughput. Throughput means number of processes executed per unit time. Always throughput should be maximum to get the output very quickly and very early. Operating system makes CPU utilization more and throughput maximum. And what are the things we have to minimize? Means turnaround time. Turnaround time is nothing but the time taken by the process to complete its execution. Always the turnaround time should be less. Waiting time means how much time that process spend in waiting for the any kind of resources or waiting for the CPU for execution. The waiting time should be always minimum. And response time is nothing but when the process requests for any of the resources, at that time the first response given by the process, that response time should be minimum. What are things should be maximum? Always CPU utilization and throughput should be maximum according to scheduling criteria. And what are the things should be minimized? Means turnaround time, waiting time and response time should be minimized. There are different kinds of CPU scheduling algorithms. Depends upon their strategy, mode of functioning, they are categorized into first come, first serve, priority scheduling, shortest remaining time, shortest job first, round robin scheduling and multi-level queue scheduling. Each one will have a specific functionality and features. In first come first serve CPU scheduling algorithm, it is one of the simplest form of CPU scheduling. How it will works means whichever process comes into ready queue first will be given chance to execute by the CPU first. For example, whenever we are standing in a queue to collect movie tickets, whichever person comes first will get the ticket first. In same thing, whenever we are collecting a tickets for bus reservation, whoever person comes first in the queue will get the tickets or reservation first. Like that, whichever process comes first will be given chance to execute by the CPU first. This is how all the processes are in ready queue. Process P1 comes first and given chance to execute by the CPU first. All other remaining process should wait until process P1 completes its execution. The first come first served algorithm will only available in non-preemptive mode. This is how we will understand this CPU scheduling by one example. There are 5 processes P2, P3, P4, P1 and P5, and arrival time, each one will be in milliseconds, and burst time is nothing but CPU execution time, how much they need to CPU time. In this process P2 comes first and it will given chance to execute first. Its arrival time will be 0 and CPU time is 12 milliseconds. And according to first come first served CPU scheduling algorithm, which process comes first will be given chance to execute first. In this case, P2 comes first will be given chance to execute first. Till P2 finishes, P3 will not get chance to execute by the CPU. P2 finishes at 12 milliseconds, then P3 is in ready queue. After that, it will be given chance to execute. After P3 completes P4, after P1, then at last P5 will get chance to execute. How we have to calculate the time means P1 comes first, P2 comes first, that's why it has a 0 milliseconds. P1 till has to wait 24 milliseconds minus 10, 12 milliseconds. P3 12 minus 3 milliseconds. P4 20 minus 5, 15 milliseconds. P5 34, 12 minus 12 equal to 22 milliseconds. The total waiting time spent by the processes P1, P2, P3, P4, P5 will be 58 milliseconds, and average waiting time for the each process will be 58 milliseconds divided by 5 equal to 11.6 milliseconds. What are the advantages of first come first serve? Means it is very simple and easy to understand, and implementation is also very easy. Or the disadvantage part means the process with the less execution time most of the time suffer. Because if it is execution time of a CPU by the process is very less, then also it has to wait until that longer process should finish its execution. And favors CPU bound processes than input output bound processes. This is another CPU scheduling algorithm, that is shortest job first. In shortest job first algorithm, whichever process having less CPU burst time or less CPU execution time will be given chance to execute by the CPU. This is how we shown in the example. All the people standing in the queue, and whichever who is small will given chance to execute. Like that, whichever process has a very less CPU time will be given chance to execute. Shortest job first available in preemptive and non-preemptive mode. Here also whichever process comes have very less CPU time will be given chance to execute. P3 has very less CPU. P3 and P4 has and P5 has very less CPU burst time. In that P4 has very less CPU time. That's why according to shortest job first, in preemptive and non-preemptive mode, whichever process have very less time will be given chance to execute. Same thing, we'll calculate the time, total waiting time and average waiting time of each process. In shortest job first are favored when it is very less CPU burst time having the process will given chance, and it is compared to first comes first serve, it is very good. The disadvantage part of the means when there are more number of shortest job, longer job should start. If there is in a queue, most of them are shortest jobs, then longer jobs continuously they have to start. They will not get any chance to execute by the CPU. In priority scheduling is one of the CPU scheduling. In this, each process is given a priority like an integer value. For example, first rank, second rank, how depends upon their marks, we will give the ranks like that. Each process will be assigned a priority. Depends on the priority, highest priority process will given chance to execute. If process P1, P2 came at the same time, if process P2 is having higher priority, it will give chance to execute by the CPU first. Till P2 will finish it, P1 has to wait. Means whichever process has a higher priority will given chance to execute by the CPU first. It is also available in preemptive and non-preemptive mode. This is the preemptive mode of explanation of a process. P2 has the priority 2, P3 5, P4 1, P1 4 and P5 3. Depends on their priority, they will give a chance to execute. Time calculation of processes and total waiting time, it gives the 49 milliseconds and average waiting time is 49 milliseconds divided by 5, it gives the 9.8 milliseconds. Priority scheduling is easier than the shortest job first, and it can cause indefinite blocking as a disadvantage. Let's have a recap. Today class we discussed about the introduction of CPU scheduling and scheduler, criteria for CPU scheduling, optimization scheduling criteria, and CPU scheduling algorithm we studied first come first serve, shortest job first and priority scheduling. In first come first serve, whichever process comes first will be given chance to execute first. In shortest job first, whichever process having CPU burst time minimal will be given chance to execute. Whichever process having higher priority will be given chance to execute by the CPU first. Thank you DCA giving me this opportunity. Thank you.